I'm delighted to open this conference. I suppose you are still relaxed, and I try to be, you know, just a second. I'm trying to be entertaining. Can you help me? Yeah. But anyway, I will present you some juicy stuff from Elixir and Phoenix internals. So I'm Alex. I'm a co-founder of Nodes.io. Are there here anybody who doesn't know what we are doing? Should I introduce myself? Okay, so we are doing, we are thinking the way how software development teams document their work. So probably you, during your career, you see this situation. From our experience, companies' internal knowledge and documents often pile up in some knowledge base, wikis like Confluence, and after a while, everything turns into a mess, and it's really hard to find the right document, determine whether it really covers the code developers are working on right now, and it's really hard to check whether this doc is relevant as of today, whether it's fresh. So we are rethinking the way how it's done, and this is our product. And with Nodes.io, you can link images, big feature rationales, PDFs, Google Docs directly with your code, with your functions, models, commits, branches, whatever, so that you always know that which lines are covered by the documentation. We also track relevance and give you answer on the question whether the doc is valid, whether it's fresh, and you can rely on it. The fresh ones are green. When the code under the document changes, we decrease this relevance factor, and we will tell you that the doc is not relevant anymore, and you have to pay more attention to that, ask your teammates, or do whatever. So I will tell you today about one of our cases that happened with Elixir, Phoenix, and some other technologies. So on our side, we have that kind of page. So it's just a page where you can choose the file to open. And it consists of several components. All these components are special components. They are written in a closure script, and we have to get the HTML from Clojure by doing such kind of thing in a Elixir template. It's kind of a little bit small, but it's large, so it's everything I could do. While doing that, in fact, Elixir and Phoenix goes over the channel and speaks to the Clojure, to the Java Clojure stuff. It's kind of poor man's microservices. In fact, we used to have ports. This is the standard way of communicating from Elixir, from Phoenix, from Beam virtual machine with some external things. Right now we are using TCP connections, but anyway, the approach the same as with ports. When Phoenix renders this template, it encounters that we have to get the information from Clojure stuff. And that's great, it works, but in fact it's blocking. So it stumbles upon the first component, it goes to the Java side, it makes some rendering, returns HTML, and during all that period, the Phoenix is just waiting. It's blocked there. So the next component, the same stuff. It is waiting for a response. Well, but we want it to be non-blocking because it could be really, really fast. Nice thing about that is that it's actually doable. We can do that components to be kind of reactive or non-blocking. But first, let me just present you a little bit of theory of how Phoenix templates works under the hood. So in fact, the templates, the result of rendering templates are just a string. But there are lots of strings in Beam Virtual Machine, in Elixir and Erlang. So here are some of them. Just a bit strings, it's just a blob of binary data, zeros and ones, just a blob. The second one, it could be a string. The second one is a binaries. This is the bit string, but with the chunks of bytes. So it's divisible by 8. The chunks of 8 bits with bytes. The third one is just a string that you write every day in a double quotes. It's a binaries, but with a valid UTF-8 code points inside. Also, Elixir and Erlang virtual machine have char lists. It's just it's from Erlang. It's the Erlang way of presenting strings. List of integers like an array, like a list. And also Phoenix strings. It's a tuple with an atom save on the first place, and then a regular string with the binary with UTF-8 code points. Okay, but also Erlang and Elixir have what is called IO list and IO data. Here's the example of putting on the console the string of hello Elixir. It could be a list of 2 elements, and if you do that, it will print you hello Elixir in one string. It could be hello. It could be a list with a string binary hello and a list of code points that was in the previous slide. You see, list of integer code points, and it will print the same hello Elixir because 69 is a ASCII code of E and so on. The same for the third line, except that on the second case we had just a single list. On the third one we have a list of lists of lists of lists and so on. So it's deeply nested. The same will the result will be the same. Hello Elixir. This way of presenting strings give us some nice features, like if you need to in that list, if we have 2 binaries that are the same, they will be allocated just one more time, just one time, and others are gonna be just a reference for that initial string. And if you want to append something to that string, if you want to concatenate, there is no reason to do new allocations. So, for example, in Ruby, if you concatenate 2 strings, the new string will be allocated, and the content will be copied from the first one and concatenated with a second one. With the I list, we don't have to do that. So the complexity of that algorithm is big of 1. Also, these types of strings are heavily used in various I/O stuff, like putting things on a console, writing a file, putting data on a TCP or UDP. The Erlang virtual machine would not concatenate that string in a one piece of data. It will just iterate over that list and will will put the data sequentially into the file or into the socket. So there's need to allocate and glue glue the strings together. So that was a bit of theory. I suppose you're not too tired. So let's get back to the Elixir and Phoenix. So we were talking about the templates, and here's how Phoenix works with templates under the hood. Phoenix on the compilation time goes through your templates on a disk. So you know that lib, blah blah blah, templates and so on. It will find all your files, all your templates. Next, if you use the standard way of processing that templates with an EEX, the EEX engine of Phoenix will process that and will convert each of your template into the function. For example, here is the simple template with a hello and h1 tag. The EEX engine will go through that template. It will subtract the parts that are never changes and will leave alone the dynamic stuff here. So never changes are in red. The dynamic part is left alone. It's all during the compilation time. Next, the serious micro magics come into play, and actually this code, more or less, but this is the central stuff of the processing unit, converts what the EX engine gets from the template. It's quoted. There it is, and just creates a function on the fly that will outputs you the your template. So that all happens in a compile time. As a result, the new Beam file will be created. In a Phoenix, it's a view file. For example, it's called page view, just a regular one, and all that functions will be placed in that view file. You have no way to just open that in your editor because it's a binary file and it's a compiled file. But we have some way to look inside it and just uncover what has happened inside. Here is the serious magic of Erlang. So Erlang has a bit of functions to work with the Beam files, and we can decompile what is in our Beam file. Here is the code. It's scary, but in fact, it will returns you the output. So here is what actually happens in a view file. It's an Erlang code. Don't be afraid. The file with an index.html name is created. Next, we get assigns and decide what are these assigns look like, and create that substitution into the template. And as a result, we have this Phoenix string. Do you remember that consists? It's a tuple that consists of two elements: the save item and the IO list of the actual input. So once again, this is the compiler thing. This is already this is the file which is ready to be executed, and it's already have strings and substitutions inside. So no compilation on the fly, like for example Ruby on Rails does. Yeah, I understand. It's really hard, but hold on a minute. The happy end is close. Okay. Okay, we have the page view. When you do render in the runtime, it gets that string that is stored in a Beam file and returns it to you, but makes a substitution. So if we have that substitution here, and it's passed through the assigns. So here are these assigns, and it's just substitute inside, and we get these Phoenix string, the tuple of save and the IO list. And it's really optimal to pass these data next to the socket because, as we discussed earlier, we just place it into the socket without needing of concatenation, all that stuff into one big large string. Okay, so this is what you can see during your work pretty regularly. Let's rewind. What we wanted to do. We have these components and we wanted to make it non-blocking. But with all that stuff, we already know how the internals of Phoenix templates work. We could try to, so we know that we get the IO list back from the template agent. And what if instead of waiting for the response from the closure part, for the HTML that returns the closure part, we place in that substitutions the task. So the task is the Elixir model, which presents the async await pattern of doing things. So we start the new procedure and get back the process ID and could go next to the next statement. So this is the simple way. This is the sample code of how to work with asyncs. So the way we work. This is the function. While the heavy work is working, we will do some more work printed on the console, and we will start waiting for a heavy work to be finished on the last line. So the idea is to, instead of passing the string into the returned IO list from the template, what if we just put the async task there, so that we stumble upon the first component, we return the task while it's going to the external stuff and rendering some work. We could go next and meet the next component, do the same stuff, the heavy request and so on, going to the next stuff and so on. So it will be, these components are going to be rendered in parallel. Okay, we get it, but we cannot put the HTML alongside with the tasks, process IDs for the user, because it's meaningless. We have to somehow wait for all those tasks to be finished, and we actually can do that really simple. We know that templates return us IO list, and we just substitute in the function render with a custom one, and we just call in. So the stock the Phoenix render function consists just with one statement. It just render template with assigns, and that's it. What if we get the same function here, get that IO list with a task PIDs inside, but also additionally process it so that just to wait for every task that we have in that list. Going through the list in Elixir and Erlang is a non-brain work. We just call in the recursive functions with a pattern match. Process rendering template, if it returns a list, we do not break the protocol. We return the list, processing the head one, the first element, and the last one, the list of subsequent elements. If we stumble up on the task that is placed instead of HTML, we are waiting. If we stumble up on something else, we don't care, we just return. So at the end of the day, and to put that logic into your template pipeline, we have to just put another use of that model in your dev.eu declaration. This is the standard one from Phoenix. And now everything goes to the external things in parallel. While these requests are just getting to the closure and waiting for the responses, that's all in a parallel. And at the end of the day, we just wait when everything comes back and put the template back to the user in the browser. So yeah, that's it. If you have questions, you can ask me. You can write me in an email if you don't want to ask me right away. And we have blog, we have a Telegram channel. Please subscribe. We just put in the random interesting stuff about startups and programming and technology there. That's it. Thank you. Thanks for everything. Please,
yeah. Any questions? Yes.
Hi, thank you for great explanations. Nice to see you again for previous conference too. So my question is maybe about global thinking, global approach about template usage. Maybe you know in production you can face this situation where you can have a large volume of these templates, and it's real coded pieces which need for some consumptions, machine time, processing time, and sometimes this template can contain some early coded pieces which can create problems for you in production system. So my question about did you face this situation where you need to provide some measurements for template rendering template? How fast it works? How much resources it need for real time? Thank you.
Okay, thanks for your question. So basically, we covered today that the templates are just a compiled piece of code, and they are stored in a bin file ready to be executed by the Erlang virtual machine. So the amount of code that you place in your template is just only up on you, because if you need that, you have no other ways you put in that. You can, just for the readability things, you can move it to the view file or view modules or in any other modules and make it more, structured. But anyway, end of the day, all that logic, all the data will be stored in your bin file. If you want it to be, if you want it to work faster, you have to reduce it. And there is no other way of doing things because it's just a code. According for the measurements, the Phoenix, as you know, prints the response time while you're doing the HTTP request, and it also puts the time for spent to render that template. And always these numbers are really, really low. Again, because it's a compiled code. You can just take a look on that. If you are not satisfied with those measurements and you want to measure chunks of code in your template, just put the timers on that and benchmark stuff, and that's it. So yeah, in the end of the day, it's just a compiled code.